We're working on several problems, some of which are very focused on the hurricane problem, how it intensifies, how it moves, some of the inner core processes that are taking place within the hurricane and how that might impact our ability to predict rapid intensity changes, and how vertical shear may tend to frustrate the development of the axisymmetric or the mean circulation. So we're working on some various avenues in the intensity problem in the hurricane area. We're also working on how hurricanes form, the genesis process, basically the self-organization, the emergence of this large coherent structure from what we observe on the satellite and radar pictures to be very disorganized, smaller weather systems. And we're working in another area, when we move from the tropics into the mid-latitudes, we're working in the area of mid-latitude mesoscale convective vortices. And we're trying to look at some of the Doppler observations from these vortices that form in the warm season over the Midwest, the continental United States, and how these vortices may influence the longevity of precipitation and how they may influence the severity of weather. I think the research we're doing right now is laying out the foundation for a new paradigm of how the small scales interact into a larger scale system, and so that these ideas will help us better improve our forecasting for incorporating the small scale behavior into the larger scale system behavior. I want to understand deeply the phenomenology of what takes place in the atmosphere and how it works. But some people might want to see how this is connected to the outside world. Why is this work important, or how can this work feed back on policy statements or climate change scenarios? And I think with a basic understanding of some of these processes, we can use that knowledge and try to use that to improve or to make future climate forecasts or future climate warming scenarios about hurricane intensity more accurate, so that there's less uncertainty. So learning more about fundamental processes helps reduce the uncertainty in some of these in these larger scale models. If we can implement those ideas into these larger scale models and reduce the uncertainty in risk assessment or climate change scenarios. Everybody knows that the motto is work hard, play hard.
Okay, good.
Work hard, play hard. So we go skiing. I have a web page, and my students and we update the web page when we go out and do activities together as a group. And we've gone skiing, hiking, So we try to do things kind of as a family or as a team, and we try to emphasize work hard, play hard.